So I think we can start. So very good afternoon to everyone who has joined, and so we'll quickly get into the topic of today's webinar. That's laser scanning for construction projects. So my name is Dinesh, and I've been associated with this Apex for last 3 years and working on digital technologies and then implementation of digital framework for projects, and then working on scan to BIM, and then 4D, 5D, and basically technology where we are helping the bringing the transformation to industry for digital technology implementation. And I did my graduation in civil engineering and then did masters in construction project management from Rec School of Built Environment. And I've started my journey from engineering in BIM and then been associated with this Apex. So that's about me. I've worked on a variety of projects. We will just see some of the case studies and projects in the knowledge sharing webinar today. And to start with the agenda, so I'll just take you through the company, about the company, what this Apex does, and then our services and those things. And then we'll get into the what is laser scanning, and then we'll see what type of laser scanners in the market, and then which is the right type of reality capture technology to be implemented for the projects. And then we get into use cases and benefits of laser scanning in construction projects. And then we'll see what is the workflow that has to be implemented or the best practices to be followed for laser scanning. And some of the sample projects or case studies that I would be sharing from my experience. And then later on we'll have question and answers. Yeah, that's so you can free to ask a number of questions, and I will try to answer your queries. Oh, Desapex, yeah, we are a digital, engineering organization. We're working on bringing the technologies or digital transformation, and for the construction projects throughout the life cycle of the project. So we do provide services in throughout the life cycle of the built asset, like during the design stage, construction, operation and maintenance, and the renovation stages. So I'll give you in detail about services that what we do on each stage of the project stages. Our mission is enable the digital adoption and integration of technology for target value design. Vision is sustainable built environment. We are headquartered in Bangalore, and then we have office where we serve the European customers in Stockholm, that's Sweden. And then we have projects all over the globe, and we've been delivering projects across the world. And so, yeah, for those of you who are not aware of ISO 19650, yes, ISO 19650 is a global BIM standard for implementation or the project life cycle for the delivery phase of the project life cycle. And we are the first company in the world and only company in India still, to get a BSI kite mark, and we are the certified BSI kite mark for ISO 19650. And all our projects follow this ISO 19650 standards, with respect to how information has to be, produced and then managed and then the delivered. So it's basically the entire, starting with how CDE and then a lot of other aspects in ISO 19650. I will explain in one of the framework that we give as a part of services how ISO 19650 will be implemented in projects. So it's basically a global BIM standard to be implemented for the projects. And customer segments, yes, we do serve, corporate real estate, residential, airports, data centers. So we've been working on a few data centers in Sweden and then other parts of the world. Logistics factory buildings here, a lot of we have digitalized a lot of factories, and then worked on some of the infrastructure projects for road projects, where we implemented a lot of technology like reality capture for progress monitoring, AR, VR, and other digital technologies. This is our team, a very young team, because the type of services and the technology that we are into is all evolving, and then our team is very capable of delivering the projects. And we have civil engineers, mechanical engineers, and then architects, and some of the sustainable background for green building. And not to forget, we have good marketing and then the team as well. So to reach the right customers and to meet their requirements. And these are the three verticals that we provide on digital design management, digital project management, and digital asset management. So under digital design management, we do provide a architectural structure and mechanical, electrical, plumbing, and firefighting modeling, where we do convert, develop the 3D models for all these disciplines, and then help on with the clash detection and coordination activities during the detailed design development phase, before generating GFCs for construction. And then BIM-based pre-construction services, where we do provide a lot of services for related to BIM, and then set up the entire framework and digital framework to bring all the stakeholders to on a single platform to run the entire project. And then digital project management, yes, as I was telling, digital information delivery plan as per ISO 19650, the standards, the CD, how the project has to be maintained through the delivery phase of the project, and then do some of the technical due diligences for the projects, and setting up the digital lab where I was talking about augmented reality or virtual reality, where we set up the digital labs to explore the model and then see, coordinate, and then have major decision makings while seeing the model in VR and AR. And then when it comes to digital asset management, that's where majorly we'll be talking about the scan to BIM, how laser scanning helps us to develop the 3D models. And then energy and maintenance management, we have a tool called Greenland Manager, where entire operation and maintenance will be, where basically we use the 3D develop the BIM models as we call a digital twin, which is a buzzword. And then we use the digital twin for operation and maintenance throughout the project life cycle or asset life cycle. Asset management, yes, where take care of the asset throughout the life cycle. In depth, when we see, so we have, let's say, we have 2D drawings, layouts, or drawing that we develop that drawings into a 3D BIM model. And once the model is ready, the model can be used for various other activities like clash coordination, quantity takeoff, or accurate cost estimation. During detailed design phase, yes, we resolve all the clashes between all the services, and then generate a clash free models where you can generate the good for construction drawings from the models. And then when the model is clash free, and then you get accurate quantities, and then which will help us to bring the accurate cost for the project, right? And then develop a shop drawings, and then 4D and 5D. Yes, 4D, or bring in the project schedule, link it to the model, and run the simulation, and have the multiple scenarios to see the schedule errors or model errors, all those aspects before we hit on the ground. So that these are the services that we provide in digital design management. And then when it comes to digital project management, is we provide this digital project management throughout the project life cycle, starting from briefing stage where we set up the entire information requirements, BIM execution plans, use cases that are being defined for per project, or what are the goals that we need to achieve for this particular project. And then when it comes to design, the model auditing, the clash coordination, and then post BIM execution plans, quantity validation of the BIM models. And during the construction, yes, training capabilities, supply chain management, create project plan reports based on plan versus actual, construction progress monitoring, all those services. And when it comes to the operation, yes, it's very important to give the transition from the construction stage to the operation, because there's a lot of gap that has been in the industry, where the models have to be updated with all the as-built information, and then these models will be used for the next 20-30 years for their operation and maintenance. So yes, we do validate the BIM models based on handover and then FM integration. That's where our Grandland FM tool comes into the place as well. And then when it comes to digital asset management, so laser scanning, I say there's a lot of buildings that may not have the present as-built drawings. So we use the laser scanning, the reality capture technology to capture the asset and then develop a 3D model from the point cloud data. And once the model is ready, yes, again, this model can be used for various other activities. So once the physical building you scan, and then you have the BIM model with you, and then add in all the non-geometrical information for that developed BIM model. And the same, when you add, say you have a geometrical model and then you add a non-geometrical information to it, and then this is actually the digital twin of your present physical building. And then this digital twin will be taken to the facility management tool of the Grandland, where we track on the asset management, energy management, and then building analytics, and then maintenance management. So that's about digital asset management. These are the three verticals, and then you have a lot of other parts in each vertical that we provide services. So this is something digital implementation framework that I was talking about as per ISO 19650. So this will be provided in three. I would bifurcate into three stages. So pre-construction stage, yes, setting up ISO 19650 framework for projects, and then develop the documents that are required. As per ISO 19650, like project information requirements, EIR, BIM execution plan, and then common data environment documents, managing 3D models, 4D, 5D, and then virtual reality. That's where the digital lab for the particular project. And then during the construction stage, yes, we have set up the entire process, and then standards, how CD has to work, how more clash coordination, 4D, 5D. So the entire things, that the framework that we set up in a pre-construction stage, a detailed design stage, has to be taken care in the construction stage. Well managed, you have to manage all the things that you have set up. And then at the end of the project, it's very important to capture all the things that has been executed back to the model. So a lot of the people many might agree and some might not agree. So a lot of people change the GFC drawings to as built and submit. A lot of things that the changes that happen on site generally don't get back to the models. So we cannot, it's very difficult even for manually to just measure, and then it may not be accurate. That's where the reality capture laser scanning technology comes into the picture, where laser scanners helps us to actually capture the present as-built conditions and then compare it with the developed 3D models, update the 3D models, and then at the end of the handover, you have the BIM model that's been updated as per the site conditions as well. So this digital twin, yeah, that's where it will be taken to the next phase. The reality capture for the existing buildings for retrofit projects, where where you don't have the present as-built drawings or the present assets that are there, present floor plans or all this. So the reality capture technology, again capturing the asset and then developing a 3D model from the scratch from the point cloud data. And then you can generate the drawings and then a renovation project. These models can be used better for renovation, or to know even say floor has to be planned in for a renovation, all those activities. So that's about the company and the services that we provide. And I think I've not taken much time for company, but yeah. So let's get into our major, discussion for that's laser scanning. So basically, laser scanning, we also call it some laser surveying or a LiDAR. So as a technology used, it's precise three-dimensional representation of objects. What it basically does is, so it hits the object and then reflects back. So and it gives us the complete point cloud or a mesh data around that particular object. So when you have captured the entire space, at the end you have that entire each station stitched together, and you have a complete point cloud data. And this point cloud data will be the base for the team to do the modeling. So you bring in this point cloud data to the authorizing modeling tools, like Revit or any other available tools in the market. Then use this point cloud data and then develop a 3D model from this point cloud data. So that's about a little bit laser scanning. What you're seeing here is this couple of scanners. So Trimble X7 and then RTC 360. So we have in-house three cameras, three laser scanners, and we've been providing services all over the world. And let's get a little more deep into the type of laser scanners. Yes, you should know what are the types of laser scanners that are available. So starting with the terrestrial laser scanners. So these are usually used for detailed surveying and mapping of the buildings, infrastructure, or landscape. The couple of scanners that you see here, these both are the terrestrial laser scanners, which will be mounted on a tripod and will be keeping it in one station. You capture that particular area and then move to the next and then again capture. And then each of these stations were being stitched together. If you see the second picture, these are the red marks of the station points, and then where each station is been linked with other station. And then at the end, you have a stitched entire point cloud data of that particular area. So then when it comes to the mobile laser scanners, these are used for large scale mapping like road infrastructure surveys or city modeling. So mobile laser scanners can be fixed onto a vehicle, or it can be fixed to a drone where you can fly these mobile laser scanners and then capture the entire space quickly if it is a large scale mapping. And airborne laser scanners, yes, this will be fixed to the airplane or flight for a forest or environmental monitoring to get the entire terrain mapping of the huge area. So those are the scanners. And then handheld laser scanners. So these scanners are very useful in a confined spaces where we don't have opportunity to run the drone or even use the traditional laser scanners. So where the accessibility is very limited. So yes, handheld laser scanners will play a major role in capturing. We can hold it in hand and then walk through the entire space, and then the entire point cloud will be generated. So these are the types of laser scanners. Majorly, we for the lot of our buildings and then mapping or infrastructure, we use the traditional laser scannings, and then for the large scale mapping or road infrastructure, we go with the drone with that, or a fixed to the vehicle as mobile laser scanners. So let's, yes, we know, we have just seen what is the laser scanner and then types of laser scanners, which laser scanner to be used for which type of work or project. So let's get into what are the use cases, where all this laser scanning, or what are the benefits that we get from this. So when we start with retrofitting projects, So say we are going to renovate certain projects, and then you don't have the present. It might be they might be having very old drawings. During this life cycle of that particular asset, there might be a lot of changes. Floor plans might be changed, or additional things might be added. So you basically don't have the present as built drawings with you. That's when we use the laser scanners to capture the entire space, and then generate the geometry of that particular building, and add in all the other information for take it to the forward. So that's one of the use case. Yes. And then as built documentation, this is the next very important that I would say. As I was already mentioning, that GFCs just turn into the as built drawings, and they've been submitted. There will be a lot of changes that would have happened at site, which is not brought back to the model. So that's where we scan the entire space, and then bring the as built back to the model, and then update based on this point cloud data by comparing the BIM model with the point cloud data, and then you have the accurate as built model at the end of your project, right? And then record the model is again, so when you have certain assets, and then yes, you generate the floor plans, and then you see above ceiling, you scan the above ceiling services, and then along with that, you can actually have this number of rooms, and then furniture, or all the available live loads can be also. So this record of this entire model will be helpful for or them to understand their loads, and then which can be used for their structural analysis when they are renovating the project as well. So that's one. And then construction progress monitoring with the reality capture technology. This is very of my favorite, or close to heart use case. So this is during the construction phase, where you progressively scan the site that is being executed, and then bring that point cloud data back to the model, and then compare it. And then this progressively gives you the actual work that has been performed. Along with the work that has been performed, you can actually validate the work that has been done, and if there is any changes, deviations that have happened, also can be updated progressively. So at the end of the project stage, you have the recorded model, and then recorded as built model, which can be delivered as a handover, where you can do the plan versus actual and all this. Basically, now we generally see and then update. So, okay, this is what is being done. So one of the use case I would like to just put it here, Klaus, say for recently we have did for one of the earthwork, where we progressively captured the site, and then given the quantity of work that is being actually excavated on a weekly basis. So that's, there are a lot of use cases like this during the construction project monitoring benefits, I would say. And then floor flatness, and then floor levels. This is very important in certain projects where they have to maintain the floor very flat, or in some of the projects where you need to provide this much slope, so that the movement of water flow and other things. So that's where we can just scan the entire space, and then generate the floor flatness reports, and then we basically give the contour, and then the higher levels and the lower levels, so defining the slope. So these are the reports that will help us to identify the lower and higher areas, or the elevations, or the slope directions of the present area. The risk assessment, where yes, we need to have the proper document of the physical assets, so that it will be huge impact, building inspection for many activities like insurance and other activities. And also some of the recent so UK has given some of the reports that all their buildings has to be audited, and then have this minimum fire guidelines. So we need to have the present as built models ready to do those audits. So there's a huge use case there as well for reality capture. When it comes to digital twin, as I told, yes, for the existing buildings, we do scan those, and then make a digital twin of their physical building, and then take that for the operation and maintenance by enriching all the non-geometrical information. Mapping and surveying for some of the topography to understand the ground profile for cut and fill or any other activities. So scanners can help us to get us the elevation models, contour lines, terrain analysis, and then topography maps of this present ground profile. And then last but not least, this heritage preservation. A lot of our heritage um, uh, has been recorded, and then this is been saved. So laser scanning is been utilized to preserve the historical sites and monuments. So these are some of the use cases, and then opportunities or benefits that we all have with the help of the laser scanning. So get into some of the, we'll like to explain in detail about some of the use cases, like take it digital construction progress monitoring. So we have the 3D model. So then you have the project schedule. So when you link together and then you run through, you actually can see the virtual construction or virtual simulation of your construction. And then during the construction phase, yes, we how do we bring the actuals back here? We use the laser scanners, and then bring the actual work that is being performed at site, and then compare it with the model, and then see if there's any deviations, and update the BIM model. Also validate the work that is being done. So this entire process helps us to actually validate the work, get the actual work done. At the end, you have the as-built verification and documentation and of your work that is being done. So that's where the laser scanning, now there are a lot of latest technologies, like where scanners have been fixed on robots, and then they move across the site and then capture the entire work that is being done, and then compare with the model later. Yeah, that's one traditional versus laser scanning methods. Again, I was talking the same concept of bringing back the updating the GFCs with the actual saying as built. So yes, there are a few areas. Yes, you can measure with manual tapes, and then get update the drawings. But there is a really gap in to meet that gap. We need to have some technology to actually capture the lot of services that have been running, and their routing might be changing. So all this needs to be updated in the model later. So yeah, so laser scanning is a best. I would say that's a solution that we need to look for, and then update your BIM models to get it as built or as built drawings. This is what I was talking about, the floor flatness using the point cloud. Use the laser scanning reality capture technology, capture the space, and then point cloud generation. And then from that, you extract the floor based on the point cloud. And then use this floor that is being generated to generate the reports. So if you see the the red markings, you have the points that you can fix the grid spacing and get the elevations at every 0.5 meter or every 0.2 meter, and then get these red ones are the higher areas in that floor, and then blue ones are the lower areas. So you basically get the floor flatness and then floor levelness report as per ASTM standards. This is some of the map with annotated deviations. So these are the lower and higher areas, and then we get the contour for that particular area. And then these points can be overlaid on your drawings to understand exact location of these elevations in the site, and then work on your floor flatness analysis. This is very useful to there are certain places where you need to there will be like floor flatness and floor levelness values that have already been fixed. So you need to have this analysis done. So it says, is it pass or fail as per ASTM standards? And these elevation points in the drawing will help us to work on to have the proper slopes or flatness for any area. So I was just give you how the workflow. So I was just explaining about the scanning and where we use above ceiling and then below based on the requirement. And then once the scanning is been done at the site, then we do register the entire scan data. The each scans each there'll be multiple stations, and then each station has to be stitched together, and then you get a single point cloud data at the end. And this point cloud data will be taken to the modeling authorized tools. So you develop the 3D model. And once the 3D model is ready, then we can be used for the various applications. You can extract the drawings and then BOQs, and then can use this model and then compare the site data. And then same model can be used later if there's any change need to develop again the entire model. You can scan that particular portion and then compare it and then update your models. So that's about the workflow. So this is the scanning, and then from once the scanning is done, you generate a point cloud data, and then later using the point cloud data, you develop a 3D model, and then later the drawings. So some of the use cases where we're comparing the model with the site conditions, whatever has been executed, and then these reports help us to be make the project on track, and then use for the during the entire construction progress monitoring. And this some of the underground utilities as well, to know the exact ground RLs, so that to know the exact positioning in the landscape, and then at what depth these pipes are all running. This scanning can be used here in this. And these are some of the images from the executed projects. And this is the registered point cloud data. And then the model is being developed from the point cloud data. And these are some of the drawings that has been extracted from the model. So I'll just quickly show uh, how the entire scan data look like. Yeah, hope you can see my screen. So you have this office space. So along with the scan data, you actually get the 360-degree image, and then this entire walkthrough of the site. So this is one of the office space. I think there's some issue with the internet. It's yeah.